All right, so chapter 4, problem 35. A nurse pushes a cart exerting a force on a handle downward at an angle of 35 degrees below the horizontal. Loaded cart has a mass of 28 kilograms. And the force of friction is 60 newtons. Draw a free body diagram for the system of interest. So the system of interest is the cart. All right, and so if we look at the cart, what forces are exerted on it? Well, there's the force the nurse is exerting at 35 degrees below the horizontal, right? But we don't know what that is yet. There is the 60 newtons of friction. There's the mass, the weight of the cart, which is 28 kilograms times 9.8 meters per second squared. That gives us this 270 newtons. And then there's the normal force exerted up where the cart touches the floor. And the normal force is more than just the weight, because if we look at this vector force that the nurse is exerting, right? There's a component that goes straight, and there's a component that goes straight down. And the component that goes horizontal is just going to be, let's see, that's going to be whatever her force is times cosine of 35 degrees, right? Because that is the angle next to, that is the side of a triangle next to the angle. And over here, that force will be whatever force she is doing times sine of 35 degrees, right? So the question is, and this would be the free body diagram, right? Question is, what force must the nurse exert to move at a constant velocity? Well, to move at a constant velocity, she needs to exactly cancel out the 60 newtons of frictional force. So we need for this component up here, this F cosine 33 degrees, to be equal to S cosine 35 degrees, to be equal to 60 newtons. All right, we need that to be equal to 60 newtons. All right, that's what we learned from the free body diagram. Now let's get, so we need force of the nurse times cosine of 35 degrees to be equal to 60 newtons, right? So that means we need the force the nurse exerts to be equal to 60 newtons divided by cosine of 35 degrees. Okay, let's pop over to Excel and let's get what this is. All right, so cosine of 35 degrees, cosine of, so we have to convert degrees to radians for Excel, so radians is the function we use there. All right, that's the cosine, 35 degrees, and we've got 60 newtons is what we want to be dividing that into. Okay, so 73 newtons. We get 73 newtons is the force the nurse exerts, right? This means this puts her at constant velocity, because at 73 newtons, the force she's exerting exactly cancels out the frictional force. And that's it for problem 35.